Today we're going to go over binary search, but before actually diving into what binary search is, I want to first go over what linear search is. And if you have a strong grasp of what linear search is, you can skip over this function or this section. But I think it's good to go over what linear search is before going over binary search so that we can kind of compare those two. Okay, so linear search. Linear search is a searching algorithm. They're both searching algorithm where it searches for an element in a sequential order. So it goes in order, starting with the first element in the array, and it goes through the array in order until it finds the desired element. So let's say that we have a array 1, 2, 3, 4, 5, 6, 7, and 8, and we want to look for value 1. So what this is going to do is this linear search is going through all the items in the array starting at index 0. And if it finds it, it's just going to return that index. And if it doesn't find it, it's going to return -1. So we have our code here, linear search, and it does exactly that. Starting at index 0, it's iterating through all the items in the array. And when it finds a value that's equal to our value, it's going to return that index. If not, if it doesn't find that value, it's going to return -1. So what is time complexity for linear search? Well, best case is all 1, because if number 1 is the first item in the array, we don't have to loop through the rest of the array. So we only loop it once, which is O of 1. Our worst is O of n, because if we were to look for the value of 8, we would have to iterate our array to the last element. Worst case, we would have to iterate O of n time, where n is the input size. And for space complexity, it's O1, because how many variables are declared? Well, we only do 1, where we're setting I is equal to 0, and this is O of 1. Now, let's go over to what binary search is. So we know what linear search is. Linear search is pretty straightforward, but what is binary search? Binary search is also sorting algorithm where it searches for an element where the element is always searched in the middle portion of the array. The array has to be sorted. This is really important. The array has to be sorted in order for binary search to work. So just an overview. Let's say that we have our same array 1, 2, 3, 4, 5, 6, 7, and 8, and we want to look for the value 1. What we're going to do is we're going to get the middle index and compare that middle number to our value. So our middle value for our first iteration is going to be 4. And then we're going to compare. Is 1 less than 4? Well, it is, right? So what we're going to do is we're only going to search the left side of 4. Well, why is that? Well, remember, the definition of binary search is that array has to be sorted. So if this array is sorted, we know that we don't have to loop through the right side of array, which is this. So we just ignore this, and you can see that we cut the length of the array pretty much in half, right? So we're disregarding the whole right half of the array, and we're only looking at the first 3. And obviously we don't have to look at number 4 because number 4 is less than 1. And then after that, we're going to get our middle element again. So we have our 1, 2, and 3, and middle element is going to be 2. Well, is 2 bigger than or less than 1? Well, 2 is bigger than 1, so we're gonna disregard our right side of the array again. So get rid of this, and then we only have one array, and we find that value, and we just return index of 0. So why is it binary search? It's binary search because we're having the number of operations as we are going through our search. We got rid of the first half, we got rid of the second half, and here we only have one element, so we just find it in our third loop. Now, as for time complexity, best is O1, where O1 would be when we are looking at our middle element, which is 4, and our value that we're looking for happened to be 4. So that will be one operation. So it will be O of 1. Our worst is O of log n, and this is when searching value is the last element, and this was the case when our value was 1. This value happened to be the last value, and this is the value that we're looking for. So this is O log n. And if you remember from our time complexity, What is log n? Log n is when we are having the number of operations. So from 8 to 4 to 2 and to 1. And space complexity, we'll go over that when we code our example, but it's going to be O1. If you looked at, again, time complexity video, you'll probably know why, but if you don't, that's fine because we'll go over it. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our solution. And first solution is going to be a iterative solution. So these are the pseudocode. Try reading it and then try to implement the code yourself if you can. If not, that's fine because obviously we'll go over it. But to just go over the code itself, first thing you want to do is create a function named binary search that takes in two parameters, value and the array. And value is the value that we are looking for. Second one is to declare a variable left and right, where left is the first index and right is the last index. So left and right is going to be representing indexes, while left is less than or equal to right. So we're going to make our while statement. We're going to declare a variable that points to the middle index, and we're going to round down. If the value is equal to the middle element, if so, we are going to return the index. And if it's less than the middle element, we are going to reset the right index to middle index minus 1. So if our middle value is 4 and our searching value is, let's say, 1, we want to look at the left half of the array, right? That's why we are doing middle index 1 and we are setting that to right. So right index is going to be this. And this is the other case. If value is greater than 4, we want to look at the right side of the array, and that's why we're doing middle index plus 1. We want to start here. And lastly, we want to return minus 1 if the value is not found. Let's start coding. So first thing, left is equal to 0, and let right is equal to array dot length minus 1. So last index. I'm going to make my while loop. Left is less than or equal to right. I'm going to make another variable, let mid is equal to math.4. I'm going to round down. You can round up if you like. That's totally up to you, right? So this is our middle index. What I'm going to do is now is our statement. If value is equal to array at index mid. So if the value is equal to the middle element, what we're going to do is we're going to return that index. Now, else if value is less than array.mid. So we're searching left side of the middle index. What we're going to do is reset right index to mid minus 1. And now is the other case when value is greater than mid. You can type else if value is greater than array at mid, but we're not going to do that. We're just going to say else left is going to be mid plus 1, and obviously because this is shorter. And here we're searching the right side of the array. And then lastly, it's going to be return minus 1 if we don't find the value that we want. So when the searching value was 5, it returned the index of 4. If it's 1, it should return index of 0. If it's 8, it should return index of 7. And if the value is 10, it should return minus 1 because we couldn't find the value. So this is binary search, iterative solution. Now let's go over our recursive solution. I think this one is a little bit more trickier, but try it a go. If you can do it, that's great. If you can't, come back to the solution. Now let's go over our pseudocode. First thing is create a binary search function where it takes 4 parameters, value, array, left and right, and we are giving default values of 0 for left and right is going to be the last index. Second thing we're going to do is make a variable that points to the middle element. Next thing is check if the value is equal to the value that we are looking for. So check if the middle element is equal to the value that we are looking for. And if it is, you're going to return that middle index. And next is going to be check if left minus right is equal to 0. And if it is, you're going to return minus 1. So this one is really important, and this is what's different from our previous example. So what this line does is if we don't find our element, it's going to return minus 1. And remember, we are changing our left and right element or index as we go through our binary search. And if it becomes 0, it means that it couldn't find the element. So that's why we are returning -1. And else if the value is less than the middle index, recursively return binary search and then set right index to middle index -1, because if 4 is less than the value or greater than the value that we are looking for, let's say that this is 1. So if 1 is less than 4, we want to look at the left side. And if it's the other case, if our value was greater than 4, we want to look at the right side. Okay, now let's start coding. So const mid is equal to math.for left plus right, and then we're gonna divide by 2. Next one is going to be our if statement. If value is equal to array at index mid, so if we found our element, we're going to return that index. And else if left minus right is equal to 0, what we're going to do is we're going to return -1. So if it is a case that we couldn't find our value, we're going to return -1. And else if our value is less than array at mid, we're going to recursively run our function, return binary search, and we're going to pass in value array, which doesn't change. And our left won't change because we're looking at the left half of the array, but our right index will change. So it's going to be mid -1 because we want to look at left of mid. So that's middle index -1, which is here. Now it's the other case, else. Well, you can do else if value is greater than array and mid, and then do your code, but else obviously refers to when it's the other case. So we're not gonna write that, make it short and simple. Return binary search, pass in the value, array, which does not change, and left is actually going to change this time. So it's going to be mid +1, and then right is going to be the same. Now, remember, this is the case when the value is greater than our middle element, which is this part of the array. So we are actually done coding. So if we were to look for number 1, we get index of 0, which we got. What if we were looking for 8, we should get 7, which we got. And lastly, a number that's not in the array, so -1. And here's our result. And this is it. This is binary search.